All right, Coach, Teacher Jerry here. So we're going to go through the second part of the reaction rate, which is the graph, right? Because the second objective is that after you understand how the factors affect the speed of reaction, able to explain, but how are we going to interpret that onto graph? How are we going to interpret on the data? So the main data that we are talking about is mainly the graph. As you can see, actually the graph will have 2 points. Right, this one as usual, we know the gradient speed, so no issue, but this is the one that we people tends to forget. Right, the volume of gas produced, that means where it ends, all right, is actually equal to the mole of the limiting reactant. And mole means volume times concentration. All right, not just only volume or just only concentration. This is based on a mole concept, right? Concentration times volume. So if you look at this, okay, and of course, sometimes we need to be aware is that faster doesn't always means that they produce more gas, right? When something is fast or when somebody is running faster doesn't always means that he's running a longer distance. Okay, so that's something we have to take note. Okay, because sometimes we always assume what fast means, I can do a lot of questions. Okay, of course you can do a lot of questions, but may not get the marks that you want because it's the accuracy that counts. All right, so let's look at it again. So you got two experiment one and three. So you can see, right, both have excess calcium carbonate, but now this is a 2 mole per dm cube experiment three, and then this is 1 mole. So definitely we know that, all right, steeper because we got higher concentration. And because since we talk about excess calcium carbonate, that means, all right, the acid is the limiting. So if the volume stay the same, 50 cm cube, 50 cm cube, but now you have 2 more per dm cube, okay, your higher concentration. So actually, if you multiply, you will get more mole, right? Because for experiment 1, you will just have 50 over 1000 times 1. So you get 0.05. But experiment 3 now, you have same thing 50, but now we times 2. So you get 0.1 mole. So you can see that the gas produced is about twice amount as compared to experiment 1. That's how we check whether they have. Even if I change, I put it experiment 2. Okay, then use I use 10 cm cube. All right, I use 10 cm cube. If I say excess calcium carbonate, excess calcium carbonate. Okay, but but instead of 50, I use 10 cm cube of 2 mole per dm cube of acid. All right, then okay, we go to check 2 mole. Okay, faster. But now, what is the mole? 10 over 1000 times 2. This is 0.02. Right? But experiment got 0.05. So that means experiment 2 will be faster. Okay. But it will be producing lesser amount of gas. Right? So that's how we compare. No? We always look at the mole. Okay. To check whether the mole of the limiting reactant to check whether they have the same amount of gas produced. Right? That is something that students always tends to look back off. All right. And we also need to take note that okay, for similar acids, like H2SO4 versus HCl, right? Then this will be twice the concentration of hydrogen ions. Okay, because it's dibasic. There's two hydrogen ions here, but this one is only. So that means sulfuric acid will be faster. Even if you have the same concentration, sulfuric acid will still be faster. And sulfuric acid, because the dibasic, the mole ratio will also differ. Right? So if they have the same amount of gas produced, same volume and concentration, they may not produce the same amount of gas. Okay, let me just show you an example. This is the final one. So you see, I can have calcium Okay. Okay. I cannot use calcium carbonate. Okay. Wait later I'll explain to you why. Okay. For example, I got magnesium carbonate. I got HCl. Okay. Then I will have magnesium chloride, carbon dioxide, and water. If I got magnesium carbonate plus H2SO4, sulfuric acid, then I get magnesium sulfate, carbon dioxide, and water. So now you look at if both acids has the same concentration, of course, sulfuric acid is faster because it has two times the concentration of hydrogen ions, right? And we know that the ions that's responsible for the acidic properties hydrogen ions. So if they got same volume, same concentration, if I got one more here and I got one more here, you see, now we look at here, 2 is to 1, the gas. So if I got one more, I only produce 0.5 mole of carbon dioxide gas. But if I got sulfuric acid as one mole, the ratio now is 1 is to 1. So you produce one mole of gas. So the gas produced will be different. So to be more precise, this one is not only just the mole, but also sometimes have to check the mole ratio if the reactor use is different. Like in this case, when you compare sulfuric acid and hydrochloric acid. And sometimes sulfuric acid also form insoluble salts with calcium sulfate. So sometimes it is faster, but it may not produce as much gas because the reaction will stop halfway. So this one is more for the pure chem students where you learn about making of salts. All right, so you have to be aware is there any insoluble salt form because any insoluble salt form it will cause the reaction to stop, okay, or prevent the reaction from going to completion. So it may be faster, but it will not produce as much gas as you may have expected. So most important thing, practice, all right, then see which one is the one that you're lacking in. All right, look through this again and hope that this helps you to able to apply to a graph questions better. All right, I will catch you in the next chapter. Thank you.